Hi guys, we're on Unit 3. This is day 6. This is the last lesson of Unit 3. And we got a warm-up. And remember that it is super important to mark the givens in your picture so it helps you answer the questions. All right, so the first given up says that FA is perpendicular to AC. Remember the symbol perpendicular. Love the symbol because right in the symbol of perpendicular are the right angles. And that's what you're going to put in your picture if you find out where FA meets AC. So here's FA and here's AC. And you can see that they're meeting at A. And so there will be a right angle right there. Right? There'll be one on the other side too. You can put one there if you want. Okay, there's no way to name that one though. All right, and then the next given says that H is a midpoint of FC. So I'm going to find H, okay? And it's the midpoint of FC. So we're going to go ahead and tick mark FH and tick mark HC. Those two segments have exactly the same length. Okay. All right. So part A says to name a median. Remember that a median, okay, is a line segment. Okay. That goes, okay, goes from vertex of the triangle to the midpoint of the opposite side. And so because we already were told the midpoint is H, we just have to follow the line segment that connects H to one of the vertexes of the triangle, which will be A. And so this green line is our median. And so we're going to go ahead and say that our median is AH. Okay. Part B says name two congruent segments. Remember, those are the ones that are check marked. One of them is FH. And the second one is HC. Okay. Part C says name a pair of angles that form a linear pair. Remember, a linear pair looks like a line with a separator. And I have one great linear pair right here at H. There's my line, there's my separator, and there's that half circle, because those two angles on each side of the separator are going to add up to 180, and that's what linear pairs do. Okay, so I'm going to go ahead and highlight the one I'm going to go ahead and use first. So this is one of the angles of the linear pair. And by highlighting it, I can see what letters I'm allowed to use. And I'm going to go ahead and call that angle FHA. Okay, I'm going to go ahead and highlight my other angle in the pair. Okay, there's the other one. And I'm going to go ahead and call that angle CHA. Okay. All right. So next one, part D says name an altitude. Remember, an altitude is another word for height. And when the doctor measures your height, he asks you to stand straight up and tall, right? Stand up straight so that your body is perpendicular with the floor. Okay. And if you remember, who would make a great body here? Who would make a great altitude is FA. Okay. There's your body. There's your floor. There's those right angles. Okay. Which is what perpendicular lines have to form. So that's how I know that those two line segments are perpendicular. So your altitude, a good one would be FA. That's the one most people pick because of the way our picture is orientated. All right. However, you could also say that if you turn your paper, that CA could be your altitude. Okay. So if you turn your paper sideways, okay, you're going to see that CA would make a great altitude as well. Be good height of the triangle from C to the opposite side. Okay. All right, part E says true or false. Triangle FAC is scalene. Well, scalene means no equal sides. And just because they're not tick marked doesn't mean that they're not equal. All right. And so I don't think I have enough information to say that that's true. Okay. So I'm going to go ahead and say false. Let me show you what some evidence would be in order for that to be true. If I knew that this side was, let's say, 5, and I knew that this side was, let's say, 10, and I knew that this side was, let's say, 12. Okay, now I can say all three sides have different measurements. Now I can say that that triangle FAC is scalene. However, we don't know that this is 12. Okay. We don't know that this is 5, and we don't know that that's 10. And so there's not enough information in our picture to say that that's true, and so we say false. There's no evidence to back it up. Just kind of like in court of law, right? You have to have evidence to say something's true. If you don't have evidence, can't say it's true, okay? Even though it might look like it. All right, today, guys, we got to talk about the centroid, okay? The centroid is a point in a triangle where the medians, all three medians drawn in, come together. All right. So the medians, remember, medians are line segments that connect the vertex of a triangle to the midpoint of the opposite side. Okay. When all three of your medians are drawn in, they're concurrent, which means they all meet at one point in the middle of your triangle. Okay. So notice that the point of concurrence is in the interior of the triangles. Okay. Archimedes showed that the point where the medians are concurrent is the center of gravity of a triangular shape of uniform thickness and density. This point where the medians are concurrent is called the centroid. If you cut a triangle out of cardboard and balance it on a pointed object, such as a pencil, the pencil will mark the location of the triangle's centroid. Or if you find the centroid first and you put the pencil tip there, you'll know exactly where to balance it. Okay. The centroid is special in math because it divides the median into what they call a 2-to-1 ratio. Okay. In this 2 part, there are two equal parts. And then there's 1 equal part here. And so medians can be divided into 3 equal parts, but they contain 2 parts in one piece and 1 part in the Okay. If you also want to know, it says that the section of the median nearest the vertex is always the twice as long piece, okay, as the section near the midpoint of the triangle sides. A lot of these pictures, you can tell which is the longer piece, okay, but if you're ever unsure, the piece that's coming from the vertex will always be the twice as long piece or the double piece or the part that has the 2 equal parts in it. Okay. All right. So let's take a look at these pictures. Okay. What happens here is that this is the vertex of the triangle. This is the midpoint of the opposite side. So you can see that there are 2 equal numbers. Okay. And so that line segment that comes from the vertex and to the midpoint of the opposite side, that's 1 median. However, if you turn your picture, okay, or leave it just as is, but you come from a different vertex to the midpoint of a different side, this red line is also a median of the triangle. Okay. And if we do it 3 times, because triangles have 3 vertices and they have midpoints of each of the 3 sides, we could go ahead and draw another median. And notice right here, smack dab in the middle, they're all going to meet. And that point has a special name, and it's called a centroid. Okay, because no matter what triangle you do this on, every single time they meet there. And so some mathematician back in the day got to name that point, and he called it the centroid. Okay, all right, so here's what I was talking about before. All right, so let's look at the blue median, and everybody see this piece right here? Well, whatever that piece is going to fit into this other piece exactly 2 times. So there's 2 equal pieces here and 1 equal piece here. They're all equal though. So there's 3 equal pieces, but you have to realize 2 of them are grouped in one segment and 1 is separated from them, okay, on the other side of the centroid. And so they get to do all kinds of math with this, and that happens on every single median, okay? All right, so let's go ahead and try an example. Let's look at number 1, and it says that we have triangle QRS with medians QA, RB, and SC. And they're concurrent, meaning that they all meet at the same spot, which is at centroid P. Okay. All right, here's the first one they're going to tell us. It says that QA equals 15. So let's go find QA. And brackets are going to be 100% our friend in these pictures. So they're telling me that this whole thing is 15. Well, do you remember what I told you? That whatever this little piece is right here is going to fit into this bigger piece exactly twice. So basically this, and this are all equal. And so if there's 3 equal pieces and 15 is the whole thing, we're going to take 15 and divide it by 3, and we're going to end up with 5. So not only is this 5, but this one's 5 and this one's 5. Okay, so now we're going to go and look at the question. What do they want us to know? QP. So if I go and I look at QP, Q to P, hopefully you can see that there's 2 5s in QP. Therefore, QP, is going to equal 5 and 5, which is 10. Okay, all right, I'm going to erase my picture so we can do the next ones without getting too much going on in here. Okay. All right, so part B. Part B says if PC equals 12. So we're going to go find PC. And we don't really need a bracket on PC unless you want one, but he's right there. Okay, and so what you're going to realize is that little piece is going to happen here, but it's also going to happen here, and it's also going to happen here, right? There's 2 that fit in that double piece. And if one of those little pieces is 12, then this is also going to be 12, and this is going to be 12. Okay, so now let's look at what they want to know. They want to know SC. So if I go find SC, S to C is the whole thing, which is made up of 3 12s. And 3 times 12 is 36. Okay, all right, I'm going to go ahead and erase my picture again so we can do the last one without getting confused with the information from the other ones. All right, last one up. This one tells me that RP equals 11. So I'm going to go find RP. And you could put a bracket on RP. That's 11. And what you have to realize is that this little piece will fit into here twice. And so basically, we got to take 11 and see how there's 2 equal pieces in 11? One here and one here. So we're going to take 11, we're going to divide it by 2 to figure out what each one of those pieces have to be, and it's 5.5. So this one's going to be 5.5. This one's going to be 5.5. So that 5.5 and 5.5 make 11. And this one's going to be 5.5. Okay. And now they want us to find RB. So use my highlighter. Where's RB? R to B is the whole thing, and that's 3 5.5s. So if I go ahead and do 3 5.5s, I'm going to get the answer of 16.5. And so RB is equal to 16.5. And that's finished. All right. So on the back side, we have some more, but they're taking our numbers away like they always do in math, and they're giving us expressions with X. And so we're going to have to set up an equation and solve for X, and then we can plug in and we can kind of do the same thing that we were doing here. All right. I'll see you guys on the back side of notes.